Hello friends, welcome to my channel. This is Engineering Mechanics question paper, Isro question paper, Engineering Mechanics part 5. A circular disc of radius r rolls without slipping at a velocity v. The magnitude of the velocity at point P shown in the figure is how much? Here magnitude of velocity given means at center, let it be O. Here this point, let it be I. At P, which is at 30 degree, we have to calculate. At P point, we have to calculate the velocity. Center velocity is V. So, in this triangle, if we will draw that triangle, IOP, angle IP, both are 30 degree, and angle O, IOP, is 120 degree. So, we will apply sine rule here. IO by sine 30 equal to OP by same sine 30 is equal to IP by, we have to calculate this distance IP, sine 120. So from here IP we can get IP equal to sine 120 is cos 30 OP into cos 30 by sine 30. OP is R into cos 30 is 1 by 2 divided by cos 30 is root 3 by 2 divided by sine 30. So it's 2 by 1. 2 cancel. IP we got root 3 R. Then we will apply instantaneous center method. Velocity is distance of instantaneous center into omega. Omega is angular velocity. It's circular motion rolls. So omega everywhere it's same. Take instantaneous center at I. So VO is V already given, that distance OI into omega, and at point P, VP is IP is distance into omega. Both case omega is same. So from equation 1 and 2 we'll write V by OI equal to VP by IP. From here VP we have to calculate. VP is V into IP by OI. So V into IP we got root 3 R here. OI is given R. So finally we will get VP equal to root 3 into V. Velocity at point P, it's root 3 V. From option A is our answer. An elevator weighing 1000 kg attains an upward velocity of 4 meters per second in 2 seconds with uniform acceleration. The tension in Newton in supporting cable will be how much? G equal to 9.8 meter per second square. An elevator going upward, W is weight of that body, here it's acceleration. So uniform acceleration, so we can use v equal to u plus 8t. V given 4 meter per second equal to u is 0 plus acceleration not given a into time 2 seconds. So a equal to it's 2 meter per second square. Then for the elevator we can use t going upward, so t minus w equal to f equal to ma we will apply here, w by g into a. We have to calculate the tension, t equal to w by g a plus w. So t equal to w will take common, or w we can write mass into g into a plus here we will write mg, g cancel, then take mass common, a plus g, then t equal to mass is 1000 kg into acceleration we got 2 plus g given 9.8, so it's 1000 into 11.8. So from option 11800 Newton, from option D is our answer. A block weighing 981 Newton is resting on horizontal surface. The coefficient of friction between the block and horizontal surface is mu equal to 0.2. A vertical cable attached to block provides partial support as shown. A man can pull horizontally with a force 100 Newton. What will be the tension T in Newton in the cable if the man is just able to move the block to the right? Here block weight W equal to 981 Newton. Coefficient of friction mu also given 0.2. Force F equal to 100 Newton. We have to calculate tension T. We'll draw free body diagram. It's F, W is downward, upward T and upward normal reaction. Here frictional force mu into N. Along horizontal force, horizontal direction, summation of all forces is 0. So F minus mu N or frictional force is 0. So F equal to mu into N. 100 Newton, mu is 0.2 equal to N equal to 100 by 0.2 or 2 by 10. So it will come 500 Newton. Then we will use this N value, summation of vertical forces equal to 0. So T plus N equal to W. We have to calculate T, W minus N. W given 981 minus N is, here we got N. normal reaction, it's 481 Newton. So from option C is our answer. To ensure self-locking in a screw jack, it is essential that helix angle is A. larger than friction angle, B. smaller than friction angle, C. equal to friction angle, D. such as to give maximum efficiency in lifting. This one already discussed in my previous videos. Helix angle should less than theta. Theta is less than equal to alpha. It's friction angle. So from option smaller than friction angle, B is our answer. Two objects P and Q are traveling horizontally with velocity 8 meter per second and 6 meter per second from left to right. They are separated by a distance of 15 meters. The mass of the objects are 3 kg and 5 kg. If the coefficient of restitution is 0.7, what is the velocity in meter per second of P and Q after impact, and when? Time also we have to calculate, and where will they impact with respect to initial positioning of Q. The corresponding answers are respectively. So it's collision question, impact collision. Two bodies P and Q. Take P as body 1, Q as 2. So initial velocity P1 U1 is 8 meter per second. For Q, U2 is 6 meter per second. From left to right, both are traveling from left to right. Separated by a distance. Let it be S. 15 meters. The mass of the object are 3 kg and 5 kg. So P mass is 3 kg, M2 mass of Q is 5 kg. Coefficient of restitution E. E is velocity of separation divided by velocity of approach. So E value given 0.7 equal to velocity of approach is U1 minus U2. Velocity of separation is V2 minus V1. So from here U1 and U2 given 0.7 into U1 is 8 minus 6 equal to V2 minus V1. So we'll get V2 minus V1 is 2 into 0.7, it's 1.4. So V2 minus V1 1.4 and V2 velocity after separation, velocity of Q and velocity of P. V1 is velocity of P after separation, and here velocity of Q is greater than velocity of P. These two things we have to remember, and from option again we have to check. From option A we have to check here 7.6 minus 5.4, and one more thing here, BQ is 5.4 and BP is 7.6. Difference also not matching, and BQ is less than BP, so both are not matching. This is not possible. Then 8 and 6 difference is 2. It is also not matching. In second case, BQ is less than BP, 6 is less than 8, so second also not matching, so B not possible. In option C, 7.6 and 6.2 difference is 1.4, so this one is matching. But second case, BQ equal to 6.2 and BP equal to 7.6. Here BP is greater than BQ, so second case is not matching. So C also not possible. So none of these is our answer. Here D is our answer. A car crashes against a wall. The initial velocity at collision is 15 meter per second and the velocity after the collision is 2.6 meter per second in the opposite direction. The mass of the car is 1500 kg. What is the average force exerted on the automobile bumper if collision lasts for 0.15 seconds? This is impact momentum principle. We have to use that one. Initial momentum plus impact equal to final momentum. M1 V1 plus force into time M2 V2. From here, initial velocity is 15 meter per second. Mass M1 equal to M2, both are same. 1500 kg. After impact, the velocity is 2.6 meter per second in opposite direction. So take minus sign. Time T equal to 0.15 second. Force exerted on automobile bumper if collision. After collision, so this one also we have to take minus. Force direction, other direction, opposite direction it will go. So put the values 1500 into V115 minus force we have to calculate after the collision. Force exerted on the automobile bumper. So F into time is, don't forget to take this negative sign. 1500 into minus 2.6. So F equal to 1500 into 15 plus 2.6 divided by 0.15, or 0.15 is 15 by 100. It's 17.6 into 10 to the power 4. So into 10 to the power 5 Newton. From option A is our answer. Thank you friends for watching my video. Thank you.